Polynomial division. I'm Anil Kumar and we will now discuss few communication and thinking questions. Here we have a very simple question, just true or false, and you need to explain your answer. The question is, if f of x equals to x to the power of n minus 1, where n is an integer and n is greater than or equal to 1, then f of x is always divisible by x minus 1. So that is the question. Now to understand it, what we are given here is the function, let me write it down here, x to the power of n minus 1, where n is an integer that is greater than or equal to 1. That means n could be equal to numbers like 1, 2, 3 and so on, right? So these are the integers which are greater than or equal to 1. So n can have any value like this, but a whole number, right? That's what we're trying to say. Now, as you know, if n has numbers like 1, 3, 5, 7, then these are the odd numbers that gives rise to odd polynomial, right? If we try to sketch odd polynomial, that is to say odd degree polynomial, where n is equals to either 1, 3, 5 or 7, that is to say odd degree, right? Then x to the power of n will be kind of a function like this. If the degree is higher, this portion will be more flatter, that is all. But it will be kind of like this. Now when we have x to the power of n minus 1, it means this function is translated 1 unit down. So if it is translated 1 unit down, it will kind of look like this. For odd degree. In any case, what we observe is, for odd degree, the function moves from quadrant 3 towards quadrant 1, crossing the x-axis at a point. Now when we say that it is divisible by x minus 1, that means x minus 1 is a factor. Factor means that point should be at 1, right? Now we know one thing, that it has to cross the x-axis, so there is definitely one point. Now is that point 1? That is that point at x equals to 1? That is what we need to debate on, right? Now if I write 1 here for x in our function, so what I get is f of 1 is equals to 1 to the power of n minus 1, which is indeed 0. Since f of 1 is 0, we know the x-intercept is at 1 and therefore x minus 1 is a factor, right? So we say therefore x minus 1 is a factor. So that is how we can prove that x minus 1 is a factor when n is odd degree. Now let us take the second case when n is even degree, right? So let's see how the graph changes. So the first case we took for odd degree. Now let us consider even degree, okay? So we are considering even degree polynomial. Even degree polynomial will have characteristic graph like this. Now depending on n, which in this case could be equals to any whole number like 2, 4, 6, 8 and so on. Higher the number, flatter it is going to be at the x-intercept or at the root. Now that is the function of f of x. How about f of x to the power of n minus 1? If we are considering f of x to the power of n minus 1, that means the parent function x to the power of n translates 1 unit down. So we can sketch it kind of like this. So that is going to be the graph for f of x equals to x to the power of n minus 1, where n is even. As you notice, it crosses the x-axis at 2 points. Now if x minus 1 is a factor, of x to the power of n minus 1, that means one of these points should be at x equals to 1. Then only it is a factor, right? So let's check it out. If I put 1 here, what do I get? What is f of 1? It is 1 to the power of any number, n. In this case, these are even numbers, 2, 4, 6 or 8. 1 to the power of any of these will be 1, right? So 1 minus 1 is indeed 0, right? So we see that at 1, it has a factor, right? It is 0. And therefore, we can say that x to the power of n minus 1, this function, is divisible by x minus 1. So since we have taken both the cases, n could be odd or even. In both the cases, x minus 1 is a factor. And that is how you can prove it, right? You'll also notice here that minus 1 is also a factor when n is even, right? So I hope that helps and make you understand the whole concept behind. I'm Anil Kumar. You can subscribe to my videos and look into more interesting questions like this. Thank you and all the best.